today we have 3 volunteers who decided that they will help me out with my project today. And my project and my lesson will be dealing with binary numbers and understanding how they're formulated, all right? So I call my lesson Counting Bit by Bit, all right? So we have volunteering Melena, Kennedy, and Michelle, all right? Now, let's just go back to 3rd and 4th grade where you were introduced to different place values in our base 10 number system, all right? So behind the decimal, we have the tenths, the hundreds, and the thousands. And then in front of the decimal, we have the ones, tens, 100, 1,000, 10,000, 100,000, and then the millions, okay? So this is what we call the different place values, all right? And within the place values, we can put the digits 0 through 9 in each place value, right? Now, in computer science, the computers recognize numbers in a different way. They recognize the numbers based off of binary digits. And those digits are only 0 or 1. Those are the only numbers that are used to identify different numbers and to store memory within the computer. All right? Now, computer science is not about just the computer or the hardware, the software itself. It's about solving problems. So the computer has to have memory in order to solve those problems, to remember, hey, what is it that we need to use in order to solve this problem? All right, and they use the binary digits in order to do that. Now, with the binary digits, it's broken down by the letters BI and IT to form the word bit. All right, now with this bit, it is represented here for different placeholders. All right, very similar to our place value chart. Each bit represents a different value. All right, a different set of numbers. All right, now let's look at this. We have 1, we have 2, then we have 4, 8, and then 16. Does anybody see a pattern that with these numbers? Anybody see a pattern? 1, 2, 4, 8, and 16.
1 plus 1, 2, 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16.
Exactly, that's right. So with our bits, they're represented off of what we call a base 2, where our numbers, our regular number system is base 10. Our binary numbers are base 2. All right. So in actuality, the way it is explained is 2 to the 1 power, 2 to the 2nd power, 2 to the 0 power, 2 to the 1 power, 2 to the 2nd power, 2 to the 3rd power, 2 to the 4th power. Base 2 numbers, okay? Now, in order for us to represent a number in the computer, all right? So let's say we want to represent the number 1, all right? The way that we would do this is look at each bit, all right? Which card will allow us to just represent the number 1? Which card? Here or here? 1 or 16? Which number would you pick? 1, exactly. So that's the only number, the only card that will allow us to represent 1. So what we will do here is our binary numbers. We're not going to use those. So, but since we will be using this one, everything else is 0. Well, I'm going to use this marker. So we represent 1. So our binary number for the number 1 is this. All right? So in our chart that you have on your paper, we're going to write that in for our binary number. So here we have our 1 in the placeholder. And then zeros in all we have to put the 0 in the front. Okay? Alright, now, let's say that we want to represent the number 2. We want to represent the number 2. Alright? Which bit would we use to represent the number 2? 2, exactly. That's just too easy to pick 2. Alright? So, we're going to cover up everything else. Alright, so I'll change this. This is now 0. This is going to be what?
2.
No.
1.
That's right, it's going to be 1. Anywhere we see the bit, we actually will see the number 1. And everything else that's covered up will be 1. So for binary numbers, we only use the digit 0 or 1. And when we see the bit, it's going to be a 1. Everything else would be 0. Okay? So now in our chart, we're going to write this binary number. For 1, we're putting what? 0. For 2, we're going to put 1, 4, 0, 8, 0, 16, 0. Alright, so now, what we have for the numbers 1 and the number 2 is what we call a binary string. Alright, this represents a binary string representing the number 1 inside of the computer as well as representing the number 2. Alright, now, let's move on a little further with the next number. Okay, it's going to be different this time. Alright, now, we need to represent the number 3. How will we represent the number 3? How will we represent the number 3?
With 2 and 1.
With 2 and 1, exactly. Exactly. 1, 2, 3. So we cover up everything else. It will be zeros here. And what would these be?
1, 1,
1, 1. That's right, because we can see that bit, those bits. My marker does not want to cooperate. Alright, so let's put that in our chart. 1, 1, and everything else is 0. Okay? Alright? Now, what do you think we're going to look for next? 4. 4. We're going to look for the binary string for the number 4. Alright? Now, I want everybody to think about it before you answer. Let's think about it. How would we represent the number 4? Tell me what you want me to do so we can represent the number 4. All right, Michelle?
Cover up 1, 2, 8, and 16, so 4 can be 1.
Cover up 1, 2, what else you said?
8 and 16.
8 and 16. All right, Kennedy, do you agree? I agree also, okay? So, here, of course, we have zeros. Let me find something that's gonna work. Maybe this one will work. Yeah, that one works. I need to put the other one in the trash can on it. All right, and this will be
1.
1. All right, so let's put that in our chart as well. All right. So we have 0, 0, 1, 0, 0. All right. Now, we have to represent the number 5 this time. Alright. 16. Why are we covering up those?
Cause they either go less than 5 or over 5.
Okay. All right. But what do we need in order to get 5?
4 and 1.
4 and 1 makes 5. Very good. So I'm not going to erase that over there. So who can tell me what I'm going to write here in my chart to represent the number 5? Kennedy?
Under 1, put 1.
Okay.
Number 2, 0.
Mm-hmm.
And then under 4, 1,
Very
put
good.
8, 0.
Very good.
And number 16, 0.
Very good. Very good. All right, now, I'm going to give you an opportunity to come up. We're going to take turns showing what we need to do for the number 6. All right, who wants to come up first? Okay. All right, Mulaney, sorry. Number 6. What are we going to cover up so we can see 6? All right, stay right here for me. All right. Kennedy, do you agree? Michelle, do you agree? Very good. All right. So let's go put it into your chart. Wait a minute. Hold on. Use your marker so I know that you did that one. All right. So you're putting zeros in. And remember, just like we would start from right to left with our base 10 numbers, we're going to start from right to left with our binary numbers. Can you do that? All right. Very good. All right. All right. Kennedy, the number 7. Bring your marker with you. The number 7. You want to take the top off? The number 7. What will you cover up so we can see 7? What do you know we're not going to use? We know you're not going to use what? 16. Okay, so we need to cover that one up. What else we're not going to use?
8.
Very good. All right, so what are we left with?
4, 2, 1.
4, 2, 1. All right, and so does that give us 7? Yes, it does. 4 plus 2 is?
4 plus 2 is 6.
And 6 plus 1 is?
7.
7. All right, so we're going to put the ones in what location on our chart? All right, very good. Okay, these are marked. All right, so now at your workstations, just go ahead and fill in your 6 and 7. Fill in your 6 and 7 on your chart. All right. Michelle. All right. You're going to do the number 8. Excellent, excellent. All right, remember we start from right, okay? All right, very good, very good. Looks like you all have a hang of it, okay? So now, at your workstations, you have your own bit cards, and we're gonna put them in order from right to left. Alright? And what I want you to do is you can either use your green sheets to cover them up, or you can turn them over. So if you turn it over, that represents 0, okay? Alright, and I want you to work numbers 9 through 12 on your own. The numbers 9 through 12 on your own, okay? To figure out what you're gonna do to get the number 9. Alright? And then write down your binary series string, sorry. And just to give you a overview while you're working, this is what we call an unplugged exercise, where we're not using the computer, we're not plugged into the computer, we're thinking through things outside of the box, outside of the computer, so you can understand what's actually going on inside the computer. Marker and go put 10, the binary string for 10 up in front. Where do we start writing from? Up. Kim, don't do that. You need your paper, remember? All right, very good, ladies, very good. That is correct. Each one is correct, all right? And it's important that we make sure we recognize this from right to left. That's how we write them in, okay? All right? Now, I want you to tell me what I'm going to write for 12. I want you to tell me what we're going to write for 12 for the first bit, number 1. What would I write, class?
0.
0. Yeah. Class, for the second bit?
0.
All right. For the 4 bit?
1.
8 bit?
1.
And 16 bit?
0.
Okay. All right, very good. Now, y'all notice a pattern with these numbers? 1, 1, 0, 1, 1, 1. 0, 0, 1.
1 and 100,000.
So we have, well, look at this, 1, 0, 1.
0, 1, 0, 1, 0.
All right, now let's look at 2. 0, 1, 1. 0, 0, 1, 1. 0, 0, 1, 1. Okay? Now let's look at our third placeholder, but it's the fourth bit. All right, our pattern is 0, 0, 0, 1, 1, 1, 1. 0, 0, 0, 0. All right, now I wonder, what is your prediction on what this next pattern is going to be?
0.
Let's look at it. You have, all right, let's start right here. You have 1, 1, 1, 1. How many ones did you have?
4.
0, 0, 0, 0. So what you think this is going to be?
1,
3
1, 1,
more
0.
Oh my goodness.
All right, so here's what I want you to do. All right, I want you to work from 13 through, let's finish your chart. Let's go ahead and finish your chart, 13 through 31. You can flip your cards over or you can use your sticky sheets to cover them up. However you want to do it, just change it up a little bit. All right, to come up with the binary number strings for the next set of digits, set of numbers, to see if those patterns continue, right? If you have any questions, feel free to raise your hand. All right, I want you all to stop for a few minutes and compare what you have so far. See if you have the same thing. You do a comparison. Y'all can talk amongst yourselves and see what you have. I think you started at number 13. Compare and see if you have the same thing for number 13.
Look at you.
It's judgment. See what you have. For 13, you look at 12, we got 13. So do y'all agree with number 13?
Yeah.
right, tell me what do you have reading from right to left, everybody? 0.
1, 0.
All right, very good. 15, read from right to left.
0,
Read from right.
1,
15.
1,
15.
Oh,
okay.
15.
Mhm.
0.
All right, let's start over with 15. She was looking at the wrong one. All right, let's do. All right, 15. What do we have?
1, 0.
All right, 16.
0, 0, 0, 1.
Very good. All right, now what we're gonna do instead of making you do all the rest of it, I want you to skip to 31. I want y'all to figure out what that binary string would be for 31. What would that binary string be for 31? All right, so let's think about it. Let's look at all of them. You tell me. That's what I want you to do. What is it? 31.
16, 17, 18.
All right, what have we been doing?
That's it.
Mm-hmm.
My brain so confused.
Okay, after 7, keep counting. 8.
9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. It's 31, isn't it?
Yeah.
So what would our binary string be for 31?
All of them.
All of them what? We will have 5 ones. That's right. We will have five ones in our binary string. Okay? Alright, so now in your free time, I'm going to allow you to finish the rest of the chart, but I'm going to move on to something else right now, okay? Alright, now, we saw this pattern. 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16. Now I need for you to tell me what will be the next 2 bits. What will be those numbers for the next 2? Alright, Kennedy says she knows. What would it be? What would be the next one? You said you knew. What would it be? Huh? 32, that's right. It would be 32, so I'm just going to put the number in there, okay? Alright. I made that one a little too big. Hold on. Y'all are different boxes. I've heard that before. Alright, what's this one? After 32. 64. Alright, very good. Alright. And Lena, what do you think this last one will be?
124.
Uh-huh.
I mean, 28.
128. Very good. Very good. Alright, so when we talk about computer science, we've heard the word bytes, right? And this byte is different from when we're eating something. Okay? Alright, this byte is spelled differently as well. Okay, it has a Y in it. Alright, so because we have 8 bits in here, alright, this is what we call a byte. Alright, the 5, we were just saying that was a binary string, but in computer science, when we have 8 binary numbers, alright, this is considered a byte. Alright, now, when we hear about, and this says that when we have 8 bytes, it actually can store more memory than the 5 bytes, okay? I mean, well, the 5 bits. So we have a byte, it stores more than these would store in memory, all right? So then you have kilobytes, megabytes, and y'all heard those terms before. It is talking about how much memory can actually be stored in the computer. So the more bytes they have, the more memory it's able to hold inside of the computer, okay? So, and it's all based off of these digits that have been generated and created, the zeros or the one, the binary digits, okay? All right, now, that concludes our lesson today. Does anyone have any questions? You have any questions?
Can we finish it?
Yes, you can finish it. Yes, please finish it, all right? And that is my lesson for our activity for today, counting bit by bit. Thank you.